Hi guys, today we will discuss about the factor theorem. So you consider the polynomial, let's say fx equals to x squared plus 5x minus 14. Okay, so how to factor this? So you multiply the coefficient of x squared with the constant term, right? So 1 times 14 is 14. Then you have to find out the factors of 14 so that the difference is positive 5. And you guys know that the factors of 14 whose difference is 5 is 7, 9, 2. So you do 7 minus 2 here, right? 7 minus 2 is 5. And x minus 14, right? And this is x squared. You distribute this. So 7 times x is 7x. And minus 2 times x is minus 2x minus 14. And then from the first two terms, you can factor out x. So this is going to be x plus 7, right? And from the last two terms, you can factor out negative 2. Then you will have x plus 7. And then you factor out x plus 7. And because x plus 7 is common, and then you have a remaining factor x minus 2. So now this is the factor form of f of x, right? And you know that this x plus 7 is the factor of fx, and x minus 2 is a factor of fx. So guys, let's see, if we plug in, let's say negative 7, right? Then what will happen here if I plug in negative 7? So it will be negative 7 plus 7, which is 0. 0 times x minus 2, you will get 0. And similarly, if I plug in negative 2, not exactly positive 2, right? If I plug in positive 2, then you will have, this should be 0, and x plus 7 times 0, whatever here, like if I plug in 2, 2 plus 7 is 9, and this 2 minus 2 is 0, so 9 times 0 is 0. So you see that f of negative 7 is 0 and f of 2 is 0, and you guys know that x plus 7 is the factor of fx and x minus 2 is the factor of fx. So now, what is the name of this negative 7 and 2? So this 2 and negative 7, right? This 2 and negative 7 are called, they are called zeros of this polynomial function fx. Okay, so this positive 2 and negative 7, they are called zeros of polynomial function f of x. So now let me write down the statement of the factor theorem. So let me erase that. So let me write down the statement. You consider a polynomial function, right? For any polynomial function f of x, this is the statement. For any polynomial function f of x minus k is a factor of fx if and only if f of k equals to 0. And by the way, this f of k is a remainder. Okay, so let me write down that this is called the remainder theorem. Let me write down the remainder theorem also here. If a polynomial fx is divided by x minus k, then fk will be the remainder. So this is the remainder theorem. Okay. So now look here, guys. So for any polynomial function f of x minus k is a factor of fx if and only if fk equals to 0. So that means if remainder is 0, because fk is the remainder, right? If fx is divided by x minus k, then fk will be the remainder. If the remainder is 0, x minus k is a factor of fx, and vice versa. Okay, if x minus k is a factor of fx, then remainder will be equals to 0. Okay, so let's do some examples. Okay, so let me erase that. And only if fk equals to 0. Okay. So now let us consider the polynomial function. So let me do one example. Okay. So determine whether x minus 1 is a factor of polynomial fx equal to x to the power 6 minus x to the power 4 plus 2x squared minus 2. So we have to determine whether this x minus 1 is a factor of polynomial fx equal to this. And we know that if x minus 1 is a factor, if f of 1 equal to 0. But what is our f of 1? This is the remainder. If the polynomial fx is divided by x minus 1, then f of 1 will be the remainder. So now we use the synthetic to find the remainder. So let's use the synthetic division. Let's use the synthetic division. So you know that we can use the synthetic because this fx is divided by what? Linear factor, right? Your divisor here, this is in the form of x minus k, right? So we can use the synthetic because the divisor is in the form of x minus k. So you write down the value of k, which is 1. You draw a line here. And the coefficient of x to the power 6 is 1. And you see here x to the power 5 is missing. So you have to write down the coefficient 0 for that. And the coefficient of x to the power 4 is negative 1. And again, you see here the x cubed term is missing, so you have to put down 0 for the coefficient of x cubed. And the coefficient of x squared is 2, you can put 2 here, right? And the x term is missing here, so you have to put the coefficient 0 and the constant term negative 2, right? So you bring down the first coefficient, this, right? And then you multiply this with this, 1 with 1, so which is 1. You write below, just below the 0. So you add 0 with 1, 0 plus 1 is 1. You repeat the same process, 1 times 1 is 1. Right just below the negative 1. You combine negative 1 with positive 1, you will get 0. You multiply 1 with 0, which is 0, right? And combine 0 with 0, so 0 plus 0 is 0, right? So 1 times 0, which is again 0. So 2 plus 0 is 2. And what is 1 times 2? This is 2, right below this 0. And 0 plus 2 is 2. 1 times 2, 2. So negative 2, positive 2, pair them up, you'll get 0. So this will be the what? Remainder, right? You guys know the synthetic division, right? So this is the remainder. You see, the remainder is 0. This remainder is exact, this is f of 1. Right? So you see from the factor theorem, so what we observe here is f of 1 equal to 0. Right? So we got here f of 1 equal to 0 because your k is 1. We got here f of 1 equal to 0. Then obviously x minus 1 is a factor according to factor theorem. Okay? So the remainder is 0. Therefore x minus 1 is a factor of fx. So let me write down here. So this implies, you can write here since remainder, what is the remainder? F of 1, right? So f of 1 equal to 0. So x minus 1 is a factor of given polynomial fx. Okay? Good. So let me do the second example. Okay? So let me do the second example. Good. So factor, so this is example. Let's say this is example 2, we can say that. Factor fx equals to 2x cubed minus 3x squared minus 5x plus 6 into linear factors into linear factors given that 1 is a 0 of fx. 1 is a 0 of fx. Okay. So 1 is a 0 of fx. So what does that mean? So that means f of 1 equal to what? 0. Right? Because 1 is a 0. 1 is a 0 of fx. So that means f of 1 equal to 0. And you guys know that this f of 1 is also the what? This is the remainder. Right? So this is the remainder. Okay? So you can use the synthetic. Again, let's use synthetic, which is very simple. Use synthetic division. So you have 1 here, you write down 1 on the left and you draw the line, and this polynomial is in a standard form, and you see the power of the variable is in a decreasing order like 3, 2, 1. So you are good to use synthetic. So you list the coefficient. So coefficient of x cubed is 2, coefficient of x squared is negative 3, coefficient of x is negative 5, right? And the constant term 6. Good. And then you bring it down. This is 2. You multiply 1 with 2. 1 times 2 is 2. Right just below negative 3. You combine this, negative 3 and 2, which is negative 1. Right? You multiply 1 with negative 1. This is negative 1. And negative 5, negative 1, you combine, you'll get negative 6. And 1 times negative 6. So it's going to be negative 6, right? So you see 6 minus 6, which is 0. This is your remainder. And you remember, you know the remainder theorem. So this is exactly f of 1, right? So this is your remainder. Because you know when the polynomial is divided by x minus 1, the remainder will be f of 1. So this is 0. Remainder is 0. Okay, so now, so what is the quotient here? So the quotient is always have the 1 degree less than the what? Dividend. This is your dividend. So the quotient here will be, so this gonna be the coefficient of x square, so 2x square. And this negative 1 will be the coefficient of x, so negative 1 times x, which is negative x, and the constant from negative 6. Right? So now we got the quotient and we got the remainder is equal to 0, and you just use the division algorithm. So the division algorithm tells you the dividend, okay, remember the dividend equals to divisor times quotient, right? You can write, yeah, quotient plus remainder. So this is your division algorithm. Or you can write down your dividend is f of x, your divisor is, because 1 is a 0, so your divisor is x minus 1, right? This is your divisor. And what is your quotient? Your quotient is 2x squared minus x minus 6, and plus your remainder is 0. You know, it's a plus 0. You don't have to write that. So now you have a fx equal to x minus 1 times 2x squared minus x minus 6. So next, you need to factor 2x squared minus x minus 6. So let me erase that. Okay. So how can you factor it? So to factor it, what do you do here? This is your x minus 1, right? If you want to factor it, let's do a side work. Or you can factor right here, okay? So it's 2x squared minus x minus 6. So you multiply 2 with 6, which is 12. What are the factors of 12 such that their difference is negative 1? So you have to find that, okay? So let me tell that again. You multiply 2 with 6, which is 12, and then find the factors of 12 so that the difference is negative 1. So you guys know that. So this is going to be what? 4 and 3, right? So you write down here 4 minus 3, because 4 minus 3 is 1, and this x minus 6. So this is 2x squared. You distribute this x, negative x, okay? Negative 4 times x, negative 4x. Negative x times negative 3 is positive 3x minus 6, right? So what is this? So from the first two terms, you can factor out 2x, so it's going to be x minus 2. And from the last two terms, you can factor out 3, so it is x minus 2, right? So now, x minus 2, this is the common factor, so this is x minus 2. And what do we have here? So you have a 2x plus 3, okay? So now, what is the complete factored form? So x minus 1 times, you know, the factors of this is x minus 2 and 2x plus 3, right? So this is the factored form of this polynomial, okay? So this is the factored form. So now we completely factor the polynomial into our linear factors. Okay. Thank you guys. I'll see you later.